We are planning on factoring trinomials of the form ax squared plus bx plus c. The difference from the problems from before is this, that now I'm going to have other numbers in front there than 1. In other words, the leading coefficient is not 1 anymore. So before we are going to look into that, let's go one step backwards. Let's multiply out these two binomials. How do we do this? We FOIL it out. Product of the first, product of the outer, product of the inner, and the product of the last terms. And when we do this, we are going to get the following. 3x times 2x, that would be 6x squared. 3x times 1. And negative 8 times 2x. And negative 8 times 1. All right, this is our polynomial as it is right now. It has 4 terms, as always, to begin with. But we see that the outer and the inner terms are like terms and they can be combined. And that means 3x minus 16x, that would be a negative 13x minus 8. All right, now here's the thing. How in the world are we going to go from here to there back to this? Because this is the process of factoring. I take a polynomial and I break it back into two terms that are multiplied with each other. So if only I would know that if I take negative 13x and I would break this into a positive 3x and a negative 16x, then there is something that I could do. Because look at this. If I may just copy this polynomial with the 4 terms, let's put this down here. Because this right here is something that we have done before. We have factored this by grouping. There are 4 terms, no GCF is to be found. I can factor by grouping. Let's do this real quick to remind ourselves how that process is working. I am creating 2 groups. Underline, do not place parentheses. Parentheses are dangerous business. So in my first group, 6x squared plus 3x, there is a GCF, 3x. And if I divide both terms by 3x, then I get 2x plus 1. Now the right one, the negative 16x minus 18, is something really good to practice because it starts with a negative, and that means that I will have to factor out a negative GCF, which would be a negative 8. If I there divide both terms by negative 8, I will get 2x plus 1. And we notice that we have the common factor of 2x plus 1, which can be factored out now. And I have 2x plus 1 multiplied by 3x minus 8. And if I now compare this with the problem at the beginning, then it is exactly what we started off with. This is the goal. The only difference is that in my original problem, I had the 2x back here. This is the same thing. 2 times 3 is the same thing as 3 times 2. So again, the real question is, how do I know how to break up this middle term right here into 2 terms? Let me use a different color, that's better. How to use this middle term and break it up into 2 terms so that then we can use the process of factoring by grouping. This might look a little bit complicated at the beginning, but if you do just 1, 2 examples, it will come all natural to you. So let me show you how we are going to do this. How to factor ax squared plus bx plus c. The first thing, we look for a GCF. if there is one. If there is one, you factor this out. Next, if there is none, like in our last example, I'm going to multiply the leading coefficient with the constant. And for this new number, I'm going to look for two factors whose sum is the number in the middle. This looks very similar to what we have done before when we factored trinomials with leading coefficient 1. Next, we are going to rewrite the middle term, the bx, and then we are going to factoring by grouping. Let's do an example. We want to factor 6x squared plus 19x plus 15. So the first thing that we are going to do is this. I take the leading coefficient and I multiply it with the constant. This number now is 60 plus 30, that is 90. Now this 90, that is now the important number. In my second step, I'm looking now for two factors of 90 whose sum is 19. I do not see those ones directly, so I slowly break this into factors. 1 times 90 is 90. 2 times 45 is 90. 3 times, let's see, 30 is 90. 90 doesn't have a factor of 4 in it, but 5 times, let's see, 5 times 14, is that right? 50 plus 20, one moment, that's not right. What do we have here? No, not 14, but 18. There we go. 5 times 18, 50 plus 40, that's 90 as well. Let's have a look. We need to go one more deeper. All right, 6. 6 times, let's have a look, 6 times 15. What else do we have? 60 plus 30, yes. And 7, no. Does 8 go in there? No, 8 does not go in there. 9 goes in there. Oh, dear Lord. Yes, of course. 9 times 90 is 90. And 9 plus 10. 9 times 10 is 90. 9 plus 10 is 19. So that means now that the numbers 9 and 10 are the magic numbers. I will now go and take this 19x right here, and I will create two extra terms. 9x plus 10x. 9x plus 10x. You broke the 19x into two terms, 9 and 10x. Which one you write first really actually does not matter. Now I have 4 terms, and we can now factor by grouping. So I'm going to look at my two groups, and in my first group there is a common factor of 3x. I'm left with 2x plus 3. Checking? Yes. In my second group, there is a common factor of a positive 5. 10x divided by 5, that's 2x. 15 divided by 5, that's 3. And we have found a common factor. The factor 2x plus 3. This one comes out right now. And I'm left with 3x plus 5. Now, before I finish this off, I'm going to double check this real quick. Always check your answer. So if I would FOIL this out, I would get, one moment, the product of the first is 6x squared. The product of the outer is 10x. The product of the inner is 9x. And the product of the last is 15. And you see already why we had 9 and 10x, because now the sum of these two is going to be 19x plus 15. I want you to notice one more thing real quick. 2x times 3x is still the first term, and 3 times 5 is still the last term. The one that was difficult to find was the one in the middle. All right, let's do one more. We are planning on factoring 3x squared minus x minus 10. So again, first thing, multiply 3 with negative 10. And I will get a negative 30. In the second question now, I'm looking for two factors who is negative 30, but whose sum is, let's see, negative 1. Negative 1 times x. So I'm going to write down negative 30. That is equal to negative 1 times 30. It is equal to negative 2 times 15. It is equal to negative 3 times 10. It is equal to negative 5 times 6. And I believe those are all of the factors. But we have to put the negative sign on the bigger number because our sum has to be negative. So 2 times negative 15, 3 times negative 10, and 5 times negative 6. And you see down here, these are the number pairs that we need. 5 times negative 6 is negative 30. 5 plus negative 6 is negative 1, which is what we have in front of here, negative 1 times x. All right, so what I'm going to do now, that was the tricky part of this question. The rest now is easier. I take the negative 1 and I break it into plus 5x minus 6x. Negative 6x plus 5x. Look, we really didn't change anything. If I wanted to, I could go backwards. In other words, this is equal to this. Negative 6x plus 5x, that is negative 1x. And now I am going to separate this into two groups that I will factor separately. And I hope that I will find a common factor. Looking, 3x squared minus 6x, there's a common factor of 3x hidden in there. X minus 2. 5x minus 10, there's a common factor of 5 hidden in there. X minus 2. And yes, we have found a common factor, the factor of x minus 2. Left with 3x plus 5. If I would check this, x times 3x is 3x squared. Negative 2 times 5 is negative 10. And the product of the outer and the inner will sum up to be negative 1x. All right, let's do another one. 8x squared minus 10x plus 3. We are going to just proceed with the same steps. First, 8 times positive 3. 8 multiplied by positive 3, that is a positive 24. And now, again, I'm looking for two numbers whose product is positive 24, but whose sum is negative 10. Now, because I'm looking for negative 10 as a sum, I am only considering negative factors. Negative 1 times negative 24. Negative 2 times negative 12. Negative 3 times, negative 8. Negative 4 times negative 6. And there we are lucky. Negative 4 times negative 6 is positive 24. And negative 4 plus negative 6 is negative 10. So the numbers that we were looking for were -4, and -6. So I am going to rewrite now the middle term as two terms, -4x minus 6x. And I combined the -6 together with the 3 and the 4 together with the 8 just because it factors nicer. Strictly speaking, you can reverse this. That does not change the outcome. So I am now going to factor by grouping. Here is one group. Here is a second group. Let's have a look. What do we have here in our first group? There is a common factor. No, let's get rid of this. 8x squared minus 4x. There's a common factor of 4x. I'm going to be left with 2x minus 1. In the right group, we have to factor out the negative of the GCF, and that will be -3. I'm going to be left with 2x minus 1. And again, we have found a common factor, 2x minus 1 multiplied by 4x minus 3. And if I would spot check this, if I just look at the outer and the last, then 2x times 4x is 8x squared. -1 times -3 is +3. All right. So let's do one last one. And this sounds a little bit funny, but it actually works sometimes. Factoring by guessing. Well, we are doing an intelligent guess. We are not just randomly trying to look for numbers. But here's the thing. If I'm planning on factoring 5y squared plus 8y plus 3, then I can do this. I could say, well, moment, all right. Maybe it factors into two factors. And these are going to be two binomials. Now, the key thing, the key observation here is this, that the first one, the leading coefficient, is prime. It is a prime number. And the last one is also a prime number. That means the product of the first and the product of the last, there is not a lot of option for you. The product of the first has to get you 5y squared. No, there really is only one way to do this. By taking 5y here and 1y right there. This would then get you the product of the first, and this will be 5y squared. Now the product of the last has to be 3. Now just because it is a prime number, there are really only two numbers that you can choose. 1 and 3. Technically, -1 and -3 are also working, but because of this between term being positive, I only have to think about 1 and 3. Now, there are really two possible scenarios. If I put the +1 here and the +3 there, or if I would do it this way, the 3 with the first one and the 3 with the last one. In both cases, the product of the last will give you +3. But the middle term would be different. So in other words, I have a 50-50 chance to get this problem right the first time. If I just leave it like this right now, how I have it last, now I will have to multiply this out to see whether I did this right. Let's do this. The product of the first, 5y times y, is 5y squared. The product of the last is +3. That we knew. We don't know the terms in the middle. So I'm going to multiply this out. The product of the outer is 5y times 1, that is 5y. The product of the inner is 3 times y. And look at this. We got it right the first time. 5y plus 3y is 8y plus 3. So, this is a valid way of doing this, but only if the first numbers the first leading coefficient and the last constant is prime. You could have done it the other way. You will end up with the same result.